Okay, let's dive into this. We've got a puzzle today that seems, well, pretty much impossible at first glance. It's a real classic, the kind of brain teaser that has tied even the sharpest minds in knots. But here's the best part. The solution is so incredibly simple, so elegant, you're going to wonder how you didn't see it right away. So get this, you've got a car and a bird, and they're kind of on a collision course, but not really. The bird is flying this crazy back and forth path. The big question, the mystery we're here to solve is, how far does that little bird really fly in total? All right, so let's start with what seems like a totally impossible puzzle. When you first hear it, you might think you need a PhD in math to solve it. But trust me, you don't. Okay, let's get into the nitty-gritty. Here's the setup. You've got a car driving from city A to city B. The distance is exactly 120 miles, and the car's cruising at a nice, steady 60 miles per hour. Now, at the very same moment the car leaves A, a little bird takes off from city B, flying towards the car at 25 miles per hour. Here's where it gets wild. The bird flies until it meets the car, then instantly turns around and flies back to city B. Once it gets there, it turns around again and flies back to the car. It just keeps doing this, back and forth, until the car finally reaches city B. The question is, what's the total distance that bird has flown? So your brain probably immediately jumps to trying to calculate this, well, infinite number of trips the bird is making. And believe me, that is the hard way. It's the rabbit hole almost everyone falls down. You'd have to figure out where the car and bird first meet, then calculate how far the bird flies back, then figure out the next meeting point, which is closer, and then the next one, and the next one. You're basically trying to add up an infinite series of smaller and smaller distances. I mean, yeah, you could do it with some fancy math, but it is a massive headache. And the best part? It's totally, completely unnecessary. You know, this gets to the heart of puzzles like this. Of course, this isn't a real-world scenario. Birds don't make instantaneous turns and fly like this. But that's not the point. The point is to be a tool, something that teaches us to look at a problem from a different angle. So, if doing all that crazy math is the wrong way, what's the right way? What are we missing? Let's take a step back and ask the essential question here. Okay, let's just stop and think for a second. We've been completely obsessed with the bird's path, right? All that back and forth, back and forth. That's the trap. That's the big distraction. But what if we asked a totally different question? What if the zigzagging path doesn't actually matter at all? For both the car and the bird, there is one thing, one single factor that is constant and unchanging from the very beginning to the very end. Any ideas what it is? This is it. This is the simple change in perspective that blows the whole thing wide open. Let's do something radical. Let's completely ignore the bird for a minute. Just pretend it's not even there. All we have is the car. The car is simple. It goes from A to B. So my question is, how long does the car travel? This is the easiest math in the whole problem, right? The good old formula, time equals distance divided by speed. The car's journey is 120 miles, and its speed is 60 miles per hour. So, you take 120 miles, you divide it by 60 miles per hour, and what do you get? 2 hours. That's it. The entire event, from the moment the car leaves to the moment it arrives, lasts exactly 2 hours. Okay, now here's the aha moment. If the car travels for 2 hours, then the bird must be flying for exactly 2 hours. Think about it. The bird starts flying the moment the car starts driving, and it stops flying the moment the car reaches city B. So the entire time the car is on the road, the bird is in the air. And if that bird is flying at a constant 25 miles per hour for exactly 2 hours, well, the math is pretty simple. 25 miles per hour times 2 hours equals 50 miles. That's our answer, 50 miles. No infinite series, no complicated calculations, just looking at the problem from a different angle. Okay, that was pretty slick, right? But you might be thinking, is that just a cool trick for this one specific problem? Well, let's find out. Let's test the theory with another puzzle. So this time, we have Tony and his dad. They're on a 1-mile circular trail. Dad is walking at a very leisurely half a mile per hour. Meanwhile, Tony is on his scooter, zipping along at 3 miles per hour. Just like the bird, he rides ahead, turns around to meet his dad, then rides ahead again, over and over. So how far does Tony travel in total? You see where this is going, don't you? It's the same exact problem, just with different characters. We have 2 problems, but really just one solution. Instead of focusing on the car's time, we're going to focus on the dad's time. The bird's path was irrelevant, and now Tony's path is irrelevant. So, How long does it take Dad to finish his walk? He's walking 1 mile at half a mile per hour, which means, yep, 2 hours. So if Dad is walking for 2 hours, that means Tony is scootering around for that exact same amount of time. And Tony's total distance is just his speed multiplied by his dad's time. So what do we get? We've got Tony on his scooter at 3 miles an hour for 2 hours, and that gives us a grand total of 6 miles. See, the same simple logic, another perfectly clean answer. This is so much more than just a clever trick for math puzzles, though. This is the problem solver's secret. It really comes down to this. In learning and doing mathematics, you've got to focus on the main ideas and not hesitate to change your perspective. That's the whole game right there. The most powerful weapon in your problem-solving arsenal isn't always some complicated formula. A lot of the time, it's just the ability to step back, look past all the noise, and find the simple core idea just by changing your point of view. So this leaves me wondering, what other impossible problems in our lives could a simple change of perspective solve? The next time you're staring down a problem that just feels way too complicated, whether it's at work or just in life, ask yourself, am I getting lost trying to follow the frantic bird, or can I find the simple, steady car?